Okay, so now is the point where you might not need to watch these videos or only be able to fast forward through some of the examples that you've tried on your own. So I'm going to walk you through all of these, stop every couple of minutes so I'm not uploading huge files, and then with a few different problems. And then if you want, you can give them a shot on your own. I would kind of point out too that there are some things that are important to note as we go through. So you do want to definitely double check your work. If you're getting a funky answer, go back and look at the walkthrough. So we did talk about this last class, the ball on a rope, car on a road. Why is it that this stuff is important to know is because that those centripetal forces are caused by something else. So if you can set that centripetal force equal to something, equal to like a recognizable force, then all of a sudden calculating for these becomes a lot more manageable. So let's start with an easy example. And this says we have a 2 kilogram ball, so mass of 2 kilograms. Moves in a circle with a radius of 10 meters. It makes 20 revolutions every 4 seconds. So our time is 4 seconds, and cycles per second is 20 revolutions every 4. Calculate, so it's looking for, this problem is looking for the frequency, the period, the centripetal acceleration, the centripetal force, and the speed. Yep, frequency and period. So let's start with frequency. Knowing that frequency is cycles per second, this is a pretty easy squeezy one. So its frequency is going to be equal to the number of cycles every second. So if we have 20 cycles in 4 seconds, then that's going to give us 5 cycles every 1 second, right? So that frequency is 5 hertz. Easy squeezy. So now if we want to do the period, again, all we have to do is take the inverse of that. So period is going to be equal to 1 over the frequency. So that's going to give us 0.2 seconds. So the next thing that it asks us to calculate is the centripetal acceleration. And from the outset, it seems like, well, we don't have enough information to do that, but we totally do if we go dig back into our previous equations. And we will find that there is an equation for centripetal acceleration on this, and it's kind of the long one. It's 4 pi squared r over t squared. Now, if you guys notice, my speech slowed down a little bit. That's because that is a long equation, and I want to make sure I'm not messing it up. So you make sure you do the same thing or follow that same procedure. So if we have 4, so we're going to start with 4. We're going to multiply that by pi squared. We're going to multiply that by our radius, which is 10 meters. So 4 times pi squared times 10. And we're going to put that over the period squared, so 0.2 squared. So I'll give you guys a second to bang that out in your calculator. We're going to get a really, really ridiculously high number, and that's okay because this is on a 10-meter rope. If we think about this, like, does our answer make sense? On a 10-meter rope, it's making 20 revolutions every 4 seconds. That is fast. So we are accelerating at 98.69 meters per second squared. Looking at that, we should probably pull that up to 1 sig fig. So we would take that right up to 10,000 probably. So if we want to do this with sig figs, 10,000 meters per second squared. So that gives us our centripetal acceleration. So far, frequency, period, centripetal acceleration. And now if we want to do the centripetal force, that becomes pretty easy because now we have an acceleration and we have a mass. So all we have to do at that point is multiply that. So our centripetal force is going to be equal to mv squared over r. So again, velocity squared over r is that acceleration. Multiplied by the mass, it's mass times acceleration. And when we hammer that guy out, we get somewhere around, we get 2, if we take the original number, 2 times 98.69, and that gives us 19,739 newtons. And if we want to sig fig that, we take that to 20, right? 20,000 newtons. And then it's asking finally for the speed. So taking a look at calculating for the speed, we get, we can take that for velocity, and we're going to go with velocity is equal to 2 pi r over t. Again, just find that equation that works for you, right? Its velocity would be that distance around times the time, right? So that 2 pi r is that circumference divided by your time. So looking at that, we get 2 times 3.14 times 10 for the radius. Is that in meters? Yep, we're good. Divided by 0.2. And that gives us 314.16 meters per second squared. So those are some basic calculations. Get comfortable with those if you need a few more examples. And then moving on from there, we'll take a look at this next example in just a second.